Hi everyone, welcome back to my video about programming in Go. This video is the last part of the series about methods and interfaces. And in this video, we will cover a built-in interface for web programming. Before we begin with building interface for web programming, let's review how we implemented web servers in the Introduction to Web Programming series. In the previous examples of web servers, we always used two functions in package net/http. The first one is function handle funct, which is used to connect incoming URLs matching a given pattern to a handler function that we have to define. The second one is function listen and serve, which starts an HTTP server and listen for incoming HTTP requests. Function listen and serve takes two arguments, where the second argument is of type handler, but we didn't know what it represents, and we always use nil for the handler argument. In this lecture, we will learn what that handler type is and how to use a function listen and serve with a non-nil handler value. The handler type used in the listen and serve is a built-in interface defined in package net/http. Here is its definition. The http.Handler interface has only one method named serve_http, which takes a response writer and a pointer to request as arguments. Note that response writer is also an interface defined in the package net/http. A handler is supposed to respond to an HTTP request. The method serve_http should write reply headers and data to the response writer and then return. The http.Handler interface is a foundation of the server API listen and serve that we have learned in the Introduction to Web Programming. This server API runs forever or until the server fails with a non-nil error, which it returns. The second argument of the listen and serve function is an instance of the handler interface in the net/http package. Recall that in all our examples of web servers so far, we pass nil as this handler instance in the second argument of the server API. But then we had to create handler functions which have the same signature as the serve_http method of the handler interface. Now we will learn another way to create web servers using the http.Handler interface. So in this way, there are two steps. The first step is to create a new type that satisfies the http.Handler interface by implementing the serve_http method. And the second step is to pass an instance of the new handler type as the second argument of the function listen and serve. To illustrate the two-step way of creating web servers using the http.Handler interface, let's consider the first example, which is to create a simple web server named http1.go for an e-commerce site with a database mapping the items for sale to their prices in dollars. In step 1, for creating this web server, we have to create a new type that satisfies the http.Handler interface. This new type is database, which models the inventory. The new type database is a map type. It maps a string that describes an item to dollars. The dollars type is defined as float 32, but satisfies the stringer interface by implementing the method string of the stringer interface. The string method on a dollars simply returns a string that contains the dollar amount in the currency or accounting format. The serve HTTP method implemented by the database type simply ranges over the map and prints the items. In step 2, for creating the http1.go server, we create an instance of the new handler type, which is database, and pass that instance to the listen and serve function as the second argument. The code for this step is in function main of the http1.go program. Here are some sample outputs of the http1.go server. So far, the server can only list its entire inventory, and will do this for every request regardless of the URL. So if we type the /any as the path in the URL, it outputs the same thing as when we type in the /list in the path of the URL. Now I'm going to show another example of creating web servers using the http.Handler interface. In this example, we want to create a more realistic web server named http2.go for an e-commerce site. This web server will handle multiple paths. Each triggers a different behavior. In particular, for the path /list, it will list all items in the inventory. For a path that starts with /price followed by a query string with key item, then it will display the price of the item matching the value of key item in the query string. For example, if the value of key item is socks, then it displays the price of the sock items. If such an item is not found in the inventory, then it displays no such item. For any other path, it will display no such page along with the given path. The code of http2.go program is the same as http1.go program, except for the implementation of the serve http method on a database. So the main function is the same. We also have the same definition for dollars and database. So here the body of the method serve HTTP on a database is different. Here is the definition of the serve HTTP method on a database in the http.Go server. The body of this method implementation consists of only a switch statement, which checks the path of the URL of the incoming request against different patterns. If the given path is /list, then it prints out the description and price of every item in the database to the given response writer. This is done by the range-based for loop as in the body of method serve HTTP in the http1.go program. If the given path is /price, then it extracts the value of the key item from the query string in the URL of the incoming request. Then it looks up the database for that item and gets the price. If such item is not in the database map, then it prints out no such item to the given response writer and also write the status not found to the header of the response writer. Otherwise, it prints out the price of the item to the response writer. In the default case, that is when the incoming path doesn't match /list or /price, then it prints out no such page along with the URL of the incoming request. In this case, it also writes the status not found or error code 404 to the response writer. Obviously, in example 2, we could keep adding cases to the serve HTTP method, but in a realistic application, it's more convenient to define the logic for each case in a separate function or method. Also, related URLs may need similar logic. For example, several image files may have URL of the form /image/star.png. So we may want to write one handler function handling image files for all URLs of this form. Thus, package net/http provides an HTTP request multiplexer known as serve must to simplify the association between URLs and handlers. It matches the URL of each incoming request against the list of registered patterns and calls the handler for the pattern that most closely matches the URL. Serve must aggregate a collection of http.handler instances into a single http.handler instance. Serve must is a predefined type that implements the http.handler interface. So we can use a serve must instance as the second argument to the listen and serve method instead of implementing http.handler by ourselves. To understand serve must, let's dive into the concept of the HTTP request multiplexer. The word MUX is short for multiplexer. So HTTP request multiplexer is sometimes called a MUX. It's a component in web servers or applications that handles incoming HTTP requests and directs them to the appropriate handler or function based on specific criteria. The primary role of a multiplexer is to match the URL path of an incoming request against a predefined set of patterns. When a match is found, it determines which specific handler or piece of code should process that request. It will also invoke the matching handler. Here is the definition of self MUX in package net/HTTP. It is defined as a struct without any exported fields. That means that we cannot use any field of self MUX directly. So to use self MUX, we typically use two exported functions which are also defined in package net/HTTP. Those are the functions related to self MUX. The first function is new self MUX, which allocates and returns a new self MUX instance. The second function is method handle defined on self MUX with a pointer receiver and two arguments. The first argument is a string representing a pattern of incoming URLs. The second argument of method handle can be any value of a type that satisfies the http.Handler instance. This function registers the handler argument h for the given pattern. If a handler already exists for the given pattern, then function handler will panic. Package net/HTTP also defines another type that satisfies the http.Handler interface. Is the http.Handler funct type. http.Handler funct is a function type that is defined to be any void function taking a response writer and a pointer to request as arguments. It satisfies the http.Handler interface by implementing the self HTTP method as follows. This self HTTP method simply calls f of WR, where f is the receiver of type handler funct. W and R are the arguments of self HTTP, which match the arguments of the function f. Note that all handler functions defined in our web servers are values of http.Handler funct, because the second argument of function http.Handle funct is of this function type. Before we move on, let's summarize the types and functions in package net/HTTP for web programming that we have covered. At the center is the interface handler, which has only one method, serves HTTP. The interface handler is implemented by serve must, which is a struct type, and by handler funct, which is a function type. The function listen and serve takes a handler as the second argument. Since serve must satisfies the handler interface, we can pass an instance of serve max as the second argument of listen and serve. Similarly, method handle of serve max also takes a handler as the second argument. So in our example, we will pass a function of type handler funct as the second argument of method handle, because handler funct satisfies the handler interface. The function type handler funct is also the type of the second argument of function handle funct. And finally, function new serve max creates a new instance of served max type. Now I'm going to show you an example of how to use http.serve-must to create a web server. In this example, we rewrite the web server http2.go in example 2, but using serve-must instead of implementing the http.handler interface. Here we define the database type as in example 2, but we don't make it satisfy the http.handler interface. Instead, we will define two methods, list and price, of the database type. And those methods can be converted into the http.handler funct type. In this program, we first create a serve must instance by calling the new serve must function. Then we call the handle method of serve must on the created instance to associate different URLs with the responding handler functions, which are defined in the methods list and price of the database type. Then we use the serve must instance as the handler in the call to listen and serve. Here is the definitions for the methods list and price of the database type. They are the same as the cases in the switch statement in example 2. In particular, the body of method list is the same as the case for the /list pattern. And the body of method price is the same as the case for the /price pattern. So this is the last slide of the lecture, and also it's the last slide of the series about methods and interfaces. So let's summarize 3 ways to create web servers that we have covered. The first way is to use the http.handle funct to register handlers and use nil for the http.listen and serve function. This is the way that we use to create web servers in our lectures about an introduction to web programming. The second way is to create a type satisfying the http.handler interface by implementing the serve HTTP method with a switch statement in order to handle different patterns for the incoming URL. And then use an instance of the new handler type for the http.listen and serve function. This method was used in the example 2 in this lecture. And the third way is to create an http.serve must instance and call the handle method on the serve must instance to register handlers, and then use the serve must instance for the http.listen and serve function. This method was used in example 3 in this lecture. Thank you for watching, and uh, I hope to see you again in the next video, which is the first lecture for the next topic. Thank you.